Okay, so we want to find the tangential and normal components of acceleration. How can we do that? Well, there's some formulas we can use, and I'll write down those formulas right now. So we know the tangential component for acceleration is r prime dotted r double prime divided by the norm of r prime. Let me just check my notes. Yep, that is the tangential acceleration formula. Now remember, r prime and r double prime, all of that stuff is vectors itself, and at is a vector itself. Okay. Now you'll write down what an is, the normal vector, the acceleration in the normal direction. It is r prime crossed r double prime divided by r prime. There we go. Okay. So, let's just start by finding r prime. When I say r prime, that's r prime of t, right? I think everyone knows that by now. But let's just take the time derivative of this to find r prime. What do we get? We get e to the t. Let me make that t a little bit better. E to the t plus, comma, then negative 2e to the negative t, and then comma, negative 2. Okay. Let's find r double prime. That is e to the t, comma, 2e to the negative t, 0. There we go. Okay, well, that's a lot. We're almost done already. So now we'll take the dot product. So I'll do this in green. R prime dotted R double prime. What is that? And I'll write it right here. So it's this guy times this guy, which is e to the 2t. And by the way, dot product produces a scalar product. So let me just drag this guy a little bit down actually. R prime dotted R double prime. We get e to the 2t. Then we get plus this guy times each other, which is just going to be negative 4 e to the negative 2t. And then this guy times each other, which is 0. So this is the dot product right here. Okay. Let's find the norm of r prime. So it's this guy, and we take its norm. Let's go e to the t squared plus negative 2e to the negative t squared plus negative 2 squared, square root of course. What does that become? It becomes e to the 2t plus 4 e to the negative 2t plus 4. So that's what we get. Okay. And while we're at it, we'll also find this guy. I just want to find everything first, and then we can write at and an. Okay. So let's find r prime cross r double prime. Instead of doing the dot product of these guys, we're going to do the cross product. So e to the t, negative 2e to the negative t, negative 2, e to the t, 2e to the negative. That was a random t that turned into 2. Okay, what do we get? Well, we get another vector, and this vector will be boom, 0 here, and boom, negative, negative, so then 4e to the negative t, and then negative on the outside of this. These guys, nope, nothing, boom, boom, negative, negative, it's positive. So we get 2e to the t. Next one, what do we get? These guys and these guys. So then that's going to become what? Oh, look at that, that goes to 0, and that goes to 0. And I should have made this more clear, so I went back and redid it. When I meant that goes to 0, I meant the exponential e to the negative t times e to the t this exponential times this exponential, it turns out to be just e to the 0, which is just e to the 0, which is 1, right? That's what I meant by it goes to 0. Okay, so we get 2, then minus minus, so plus 2, so 4, right? That's what we get. Pretty nice. Okay, so now let's take the norm of that. So r prime cross r double prime, it's norm. And we're going to do this one in our head. 16e to the negative 2t, and plus 4e to the 2t, plus 16. There we go. Okay, so if we get that, right, so we have everything we need, but there's arguably some things we can do to make these guys factor out a little bit nicer. So we'll do that. I'll do it in black. Okay. This guy looks as compact as it's going to get. We'll just leave it like that. How about this one, though? Is there something we can do with this? Potentially. Okay, so I'm going to do this one in black, and I'm going to tell you guys the answer, and I'll show you why it's the answer. Originally, I did it, and it's kind of like, the way I actually got the answer was kind of like a guess and check method, which is not the best way. It's e to the t plus 2e to the negative t squared in the square root. And what I mean by a guess and check method is, okay, so you see that you have 2 times t up here and negative 2t. So you know when you have that, right, for this to be a perfect square, assuming it is a perfect square, right, that there has to be some sort of way for an e to the t to turn into e to the 2t. Okay, so then you know that it will start off with just an e to the t. And then you also know that we have a 4, so then you're going to have to put a 2 in front of one of these guys. Okay, and you could bet that the 2 should go in front of this side because there's a 4 here, but there's no 4 over here. So that's what I meant by like the kind of the logic and guess and check method to get there. And this is the correct answer, but to actually factoring it, I'll be honest, it's kind of hard to actually factor. And it would be a waste of time to kind of keep going on it. E to the t plus 2e to the negative t. So this is the norm of r prime of t. Okay, let's take the norm of this guy. Now, I'm going to tell you right now it's probably going to be nearly the same thing here. So let's say if we factored out a 4, what would happen? We would see that we would get 4e to negative 2t, then plus e to the 2t plus what? Plus 4. Okay. And there's a plus 4. So if you would note that this guy looks exactly like that. It looks exactly like that. For some reason my plus 4 is not writing here. Okay. So I had to take a break because my thing wasn't loading up. But that's what I meant, is if you factor out a 4 out of this guy, this over here is the exact same as this. Alright, so what does that mean? It means you can repeat the result, and then we just get 2 e to the t plus 2e to the negative t. Okay, so now let's go into blue and truly write everything down that we actually want here. We found all the parts, we simplified the majority of it, so now we can get the results. Okay, so we got this guy, e to the 2t minus 4e to the negative 2t, divided by what? This guy over here. E to the t plus 2e to the negative t. Maybe you could do something to kind of, you know, split it down a little bit more. I don't really know. I mean, maybe you could. I don't really care to do it. I think this is the nicest form you should put your effort into. Next one, a to the n. Okay, so we got this guy, which is this guy. 2e to the t plus 2e to the negative t. Divided by what? Divided by r prime again. Nope, do not want to do that. Divided by this guy. So e to the t plus 2e to the negative t. And as you can see, these cancel. And then we just get 2. So that's really nice. So look at that. We found 2 parts to this question. Relatively fairly simple. Just the algebra was the hard part, to be honest. Algebra is always the hard part. Okay, so we want to determine the values of t for when the acceleration is perpendicular to the direction of motion. Okay, what that means is, well, I gotta make some space. Okay, so what it basically means is we have this acceleration and it's perpendicular to what? The velocity, right? And in a sense, we could write this as, this is nearly the exact same, well, it is the symbolically same thing as r double prime perpendicular to r prime, right? And we know that, you know how dot products work. We know that the angle is 90 degrees if the dot product is equal to 0. So r double prime dot r prime. If that's true, then it's perpendicular. So then all we have to do is actually just use these results. We do have to find, we just have to use r double prime and then dot it with r prime instead of taking the cross this time, and then find that value of t that makes it true. Okay, so I'll show you guys what I mean. So r prime of t is this guy over here. So we have e to the t. It's a vector. Remember that, e to the t, negative 2, e to the negative t, negative 2. Then dotted. By the way, that was r prime. My bad. I wrote it in a little different order. It's fine because it's a dot product. It's not a cross product, so you can mix around the order. E t to e to the negative t, 0. And take that dot product and you set it equal to 0. And then what do we get? We get e to the 2t plus, it's not actually going to be a plus, it's going to be a minus 4e to the negative 2t. So that's what we get. Okay, and then remember that this is all equal to 0. So, in other words, we need to solve for t. Okay, so how you can solve for t is, well, one, I mean, you really could just use the fact that we're at an exponential. We need to find t by using the logarithm here. So if we take the natural log, and we'll take the natural log of both. So we know ln of 0 is not a good thing, actually. So before we do that, my bad, we're going to put this guy on the other side. So we'll get e to the 2t is equal to 4e to the negative 2t. Okay, now what we should do is we should try to isolate, as much as possible. So let's just try to get 4 by itself. So 4 is equal to e to the 2t divided by e to the negative 2t, in another sense, multiplied by e to the 2t, which is e to the 4t. Okay, so now if we take the logarithm of both sides, we get ln, not absolute, ln of 4 is equal to the ln of e to the 4t. And yes, you can rewrite that as 4t itself. So in other words, t is equal to ln of 4 divided by 4. So there you go. Very nice.